Hello and welcome back. In today's video we're going to cover sector area and arc length, who are very similar concepts, and how we're going to approach them, and how they are actually going to be tested on the ACT. As always, if you find it helpful, leave a like, subscribe, comment with anything you like if you want to support the channel or help others find these videos. But let's get right to it with a quick overview of what we're going to have to do on the ACT for these concepts. It's just two things. So we're either going to solve for the sector area or the arc length, or you might just even have to pick the equation that has correctly plugged in values to solve for either the sector area or arc length. So you might not have to fully solve it all the way through, just set it up. That's really all you're going to have to do. Some of the more complicated questions might mix this with a few other things where you might have to plug this equation into something else, but as long as you know these, you'll be good for those. So let's start out with sector area, just saying what is it? So a sector is just this kind of a wedge inside of a circle. So sector area is just the area of this wedge shape. So you can think of it kind of like a cheese slice and a cheese wheel, or a pizza slice and a big pizza. But this little wedge here is the sector. So sector area is its area. Now, how am I going to get the sector area? Well, that equation is going to change depending on if our sector angle, which would be this angle from here to here, is in degrees or radians. So, because of that, instead of memorizing those formulas, because now there's going to be two different ones, and if you mix them, you're going to get the wrong answer, and they will trick you to see if you do that. There's an easier way to figure this out where you don't need to memorize anything other than the stuff that you should already have memorized from my earlier videos that are very simple. So, let's break this down and how we're going to do this. Notice how the sector area is really just part of the whole circle's area. And that's going to be proportional to what fraction of the circle is taken up by the sector. Now that's a lot of words. What I mean by that, though, is if I know the area of this entire circle, and I know what fraction of this sector takes up the circle, then that fraction of the whole circle is that area. So let's look at an example with a few numbers. So let's pretend this sector here is 1/5 of the circle. Well, then if I know the area of the circle, then the sector area is just 1/5 of the area of the circle. And that's all there is to it. That's going to be the key concept for both sector area and arc length. I'll do the same thing there, where we're just going to get some property of the whole circle and just take a fraction of it. So, our circle area equation, this is the thing I said you're going to have memorized that I was pointing to. Area of a circle. So that, if you don't remember, is pi r squared. And if you didn't remember, memorize it, because they will test this. So in this case, if the sector is 1/5 of the circle, well then the sector area is 1/5 pi r squared. And that would be my formula for sector area. So now, let's figure out, well, what fraction of the circle does this sector take up? Because that was pretty simple on the earlier slide where I just told you, oh, it's 1/5 of the circle. They're never going to tell you that. What they're going to give you is just this angle and the radius, maybe the diameter of the circle instead. So how could I figure out, well, what fraction is this? Well, we're going to use this angle. So if I have something in degrees, remember that a full circle is 360 degrees. So if I start here and go all the way around, I'm going to get to 360. That's why each quadrant is 90, 90, 90, 90 until you get to 360. So the fraction to use for a sector area would be whatever my angle is over the total of 360. Or again, that angle there, that theta, is the sector angle. Now as a reminder, I've got up here the area of a circle equation. So my sector area is just going to be the theta over 360. So this is just the fraction of the sector area that I found right there times pi r squared. And that, in bold, is one thing you could memorize if you wanted to. That's the sector area formula right there. But only if you're in degrees. Now, what about if I'm in radians? A full circle is 2 pi. Remember that a line is just pi. So going to a line and then back around is 2 pi. That's a whole circle. So therefore, this angle, the fraction of it is just going to be whatever that angle is over the total 2 pi. So it's the same idea as up here, it's just we change what's at the bottom of the fraction. So now I can take this and just put it in front of the area of the circle. And I have the sector area is the theta, or the sector angle, over 2 pi times pi r squared. Now you might notice there's a couple pi's in here. Well, those pi's will cancel out, because this is in the denominator, that's in the numerator. So that leaves me with theta over 2 times r squared. This, if you look it up, is what you're going to see. If their internet or whatever book is going to tell you, here's the equation of sector area in radians to memorize. But you can see how this can get a bit more complicated if I now have 2 more equations I need to memorize, one for degrees, one for radians. And when I get to arc length, I'm going to also have 2 more. So you have the option here of just flat out memorizing 4 equations on top of everything else you're memorizing for math. Or if you just understand how to use the fraction to get to this equation, and just the area of a circle that you should already know, then you don't need to memorize anything else at all. Okay, so let's actually do some examples with some numbers. And by the way, if you notice my audio suddenly sounds different, that's because I'm actually re-recording just this slide because one of my viewers actually pointed out that I had a math error on my original version. So thank you for pointing that one out. And if anyone sees anything else like that, let me know so I can fix it. But let's get right to it. I'm going to do an example here with degrees and then another with radians, and I'll use this exact same setup for arc length later in the video when I get to that. So let's say I have a circle and the angle of my sector is 40 degrees. The radius is 3. So that means that the fraction of the circle taken up by the sector is 40 degrees, that's the sector, over 360, 360 being the entire circle. So just a reminder that the area of a circle is pi r squared. So if I need to know, well, what's the area of this sector, I'm going to figure out, well, the fraction of the circle that it's taken up by the sector, and then multiply that fraction by the area of that whole circle. So I will take this fraction and put it right here, directly in front of pi r squared. So all I did is I took, this is the circle area, the pi r squared, put that fraction right in front of it, and that's my sector area. And now, because I know the radius, I can take that 3 and plug it in here to get this. And this is where I can start doing the math to figure out, well, what does this number turn into? Well, 3 squared is 9, so I end up still with my same fraction of 40 over 360 times 9 pi. And then that 9 times 40 gives me 360. And I still have this over 360 times pi. These 360s are going to cancel out, and I just get pi. And that's my answer. So it's also a good kind of coincidence that I chose these numbers and they all cancel out. Because you might just immediately cancel this out if you were trying to just guess and eliminate, but you can end up with something like this. So now, let's go ahead and look at a radians example. So if they told us that the angle of the sector is pi over 3, and this time their radius is 5, I know that I'm in radians because I see pi instead of degrees when I'm talking about an angle. So again, I need to figure out the fraction of the circle taken up by the sector. If I'm talking radians, the full circle is 2 pi instead of 360. So it's the same thing as up here, but instead of 360 at the bottom, I'm putting 2 pi. And then again, I just take the angle of my sector and put that on top of the fraction. So pi over 3 all over 2 pi. Now if you wanted, you could cancel out these pi's right now. I'm not going to do that yet because just to keep things a little bit more trackable so you know where I am for each step, I'm just not touching anything yet. So now again, the circle area equation is pi r squared. So to get the sector area, I'm just going to take this fraction and put it in front of this. And that gives me this equation. Sector area is pi over 3 over 2 pi, that's just this again, times pi r squared. Now at this point, I'm going to choose to start canceling out just a couple of these pi's because this is starting to look messy. So it's up to you. This one's a numerator, this one's a denominator, this one's another numerator. So you can either cancel out these two, or you can cancel out this one and this one. I chose to get rid of these two just because they're right next to each other, but you'll end up with the same answer either way. So that's how I ended up going from this to this. I just canceled out those 2 pi's. Now I can plug in my radius of 5 right here for the r. Well, actually, I did one more step. Sorry, backing up. I went ahead and did the 3 times 2, so this pi over 3 divided by 2 becomes pi over 6. That's a little bit cleaner. Then I plugged in the 5. And that's how I get pi over 6 times 5 squared. Then finally, 5 squared is 25 times the pi gives me 25 pi over 6. And that's my answer. Sorry I did that a little out of order here, but you can plug things in and clean things up in whatever order you like. Hopefully you're able to follow there, and you'll always get the right answer, as long as you do all that correctly. But this is just another way of showing we can do all this without memorizing any of the formulas. Again, you can memorize the formulas if you like. I just find it's hard to add one more thing to memorize, or in this case several, because you need the different versions, and I might just mix them up. But that is up to you. So now let's move on to arc length. This one's a little less obvious what it means, but arc length is just the length of this outer edge. So if you think of circumference of a circle being, if you were to just start here and run along the edge of the entire circle, how far did you run? That's circumference. Arc length is the same thing, where if you start here and run along the edge to the other end of your wedge or your sector, that's the arc length. So I've got this bolded right here. So, how do I get this? We're going to do the exact same trick that we did with sector area, but this time I'm going to use circumference instead of circle area, because arc length is, again, just a part of the entire circle's circumference. So whatever fraction of the circle my sector is taking up, well, the arc length is going to be that same fraction of the whole circle's circumference. So we'll use the same example as before, with the sector being 1/5 of the circle. Then its arc length is going to be 1/5 of the circumference of that circle. So the circumference equation, this is the other thing you should have memorized, is pi times diameter, or 2 pi r. Most likely, you're going to want to use the 2 pi r, because if I'm looking at a sector, I'm typically just going to be given radius instead of a diameter, because I'm normally not worried about the whole circle. So that's typically what I'm going to give you. But it's up to you. Whichever you think is easier to remember, you can get from one to the other pretty easily. So, in this case, if the sector is 1/5 of the circle, then I can put 1/5 in front of either of these two equations, and I'm going to have my arc length. So 1/5 pi d, or 1/5 2 pi r. So, just like with sector area, let's take a look and figure out, well, how does this actually look with degrees versus radians? So again, in degrees, a full circle is 360 degrees. So the fraction that I'll have to use for arc length is still going to be my sector area over 360 if I have degrees. So if I plug it in and put that in front of pi d, I get arc length is theta over 360 times pi d, or if I use 2 pi r, the more common one, it's theta over 360 times 2 pi r. If you go and look up what's the formula for arc length in degrees, this is what you're going to get. So feel free to memorize those if you want, but you don't really need to if you just know we're just taking the fraction of the circumference. Now radians, just like before, a full circle is 2 pi, so the fraction for arc length will be my degrees here, or sorry, my radians, my angle of the sector over 2 pi. So if I take that theta over 2 pi and just put it in front of pi d, it's theta over 2 pi times pi d, or theta over 2 pi times 2 pi r. Now this time, again, things are going to cancel out. In either case, the pi's will cancel out, but if we use the radius, so the 2 pi r one, which is more common, the 2's will also cancel out, and that gives me theta over 2 times d, or typically just theta r. This is the simplest one, but you can only use that if you have radians. One of the most common mistakes I see is people memorize this one for arc length, and then they're given something in degrees, and they just put the degrees times r. That's the wrong answer, and it will be an answer choice, and it will be the wrong one. So again, if you want to memorize these, feel free. There's 4 of these you can look at, or if you just want to worry about the radius, this is just 2, but then you also have the 2 from sector area. Up to you. I recommend just understand how to use the fact that it's a fraction of the whole circumference. So just like with area, let's go and take a look at the same examples with the numbers. So if I have degrees, so my angle being 40 degrees, my radius being 3, the fraction of the circle taken up by the sector is going to be 40 over 360. So I'm going to use the 2 pi r one because that's the most common, and you can see I have radius here. So I'm just going to take that 40 over 360 and put it in front of 2 pi r. That's my arc length. My radius is 3, once again. So 2 times 3 gives me 6, so 40 over 360 times 6 pi. Multiply 6 times 40, and I get 240 over 360 pi. And that's my answer. Again, you can continue to simplify this fraction if you want, but to save time, I'm going to leave it right there. So now, let's look at radians. Same angle as before, pi over 3, and radius being 5. So what is my fraction going to be? Well, it's going to be that pi over 3 angle over the total of a whole circle, which is 2 pi. So, again, circumference is 2 pi r. I'm going to take this fraction, put it right here in front of the 2 pi r, and then start canceling things out. So that 2 pi crosses out that 2 pi, so then I'm left still with this pi over 3 times r. Radius is 5, so I can put that in for r, and that becomes 5 pi over 3. And that'll be your final answer. That one you're not going to simplify any further, so that's probably the way it's going to look on the test if you're given this one. And that's all there is to sector area and arc length. I know this one was a bit more of a concept one, so it might be a little confusing. Feel free to rewatch the video or reach out if you have questions, but I truly believe that using this trick as a fraction is way easier than memorizing the formulas and can help prevent some mistakes. But if you do find my way harder and find it easier to just memorize a couple more equations, that's perfectly fine. Some people do find that to be simpler. Just make sure you don't mix up which one to use for degrees and which one to use for radians, because that is one of the most common mistakes. So with that, good luck, and I'll see you on the next one.